which happens to be answer B. And you'll notice that this becomes 0.12 with significant figures. But once you get this part, you'll figure that out. So that's the answer to that question. Remember that that formula there. Percent of something is just however much percent divided by 100 times whatever you want to find the percent of. So question 8. A sample containing that many grams of metal is poured into a graduated cylinder initially containing 12.7 water, causing water level to rise 21.6. Does not dissolve. Calculate the density of the metal. So here, people, I think we're a little confused here. So, say we had this container at this level here is 12.7 mils. Say we add this metal that goes in here. So basically what you have is your metal's probably going to sink, right? So here's your metal, and your water is going to be raised a little bit, in this case to 21.6 mils. So, and that just has to do with like water displacement, right? If you fill you fill your coffee cup up right to the brim, as soon as you put your spoon in, all the water is going to drip out, right? Because you're displacing the water. So the amount of water you displace is basically the volume. So this volume of metal is going to displace the water that much. So basically, and you also got to remember, density is equal to mass over volume, right? So we know the mass is 33.42 grams, but it's the volume we don't really know. So remember, this is like I forget that guy's name, who screams Eureka because he's taking a bath and the water flows over when he steps in it, right? So it's the same concept. So basically the volume is equal to the rise in the water level. So it rises to 21.6 mils. That means it displaces this many mils, and it works out to 8.9 mils. That means our answer comes out to grams per mil, 38 grams per mil. So, yeah, this question might have been something a little tricky, but you could imagine that. Like I said, it's like when you fill up your coffee cup. You fill it up too much and you want to stir it with a spoon, you're going to push out the water, and the amount you push out is basically the volume of this, right? And that's why I had to specify it doesn't dissolve. Like if I put salt in there, it's not going to displace the water like that. It's just going to ionize. So that's what happens. That's what happens there. And you could also imagine it. Say you had a 1 centimeter by 1 centimeter cube, and and it's full of water, and you put a 1 centimeter by 1 centimeter cube inside. What you're going to end up with is the metal completely filling the container, right? And all the water is going to spill out. So you're displacing 1 by 1 volume of water.